In this video, we're going to review Gaussian elimination with back substitution on a matrix that's larger than 3 variables. So we're going to have 4 variables here, but the process is basically the same as we've done it for 3 variables, x, y, and z. It's just the same idea. And we just got to put the matrix in row echelon form just to get the values. Okay, so on top in red is a linear set of linear equations. We have 4 variables here: x, y, z, and w. So just on this last row, I'll just make sure we have that clear. That's going to be a z there. Okay. All right. So what I did here was I just changed the red linear equations into a matrix in the bottom in yellow, just with the leading coefficients. We really don't care about the variables. Those could be any variables, but the matrix is going to look the same either way. Okay. So on the top row, in the red matrix, I have y plus z minus 2w equals -3. So if you look at the first row in the yellow matrix, I have a 0 placeholder because I have no x's in that row. And I have a 1, 1, 2. Remember that long line means that's equals. So the numbers to the right of that long line here, this long vertical line here, is the answer. So I have 0, 1, 1, 2. I have a long vertical line and -3 because these first row equals -3. The reason why it's a 1 and 2 on the first row is because if I look at the first row of my top, the coefficient of y is 1, coefficient of z is 1, and actually this one should be -2 here. Just update that there. That should be -2 because this is a -2 there. Okay. So I just did the same thing for all the rows there. If you notice, the 0 in the second row of the yellow matrix is 0 because there's no w term in this top red matrix on the second row. So that's how that transformed. All right, so let's get this yellow matrix into the correct format we need. So I have 0, 1, 1, -2, -3 here, 1, 2, -1, 0, 2, it's -2, -19. I have 2, 4, 1, -3. And the last row was 1, -4, -7, and -1. So that was our matrix that we have in the previous example. Okay. So, all right. So we want to get this into row echelon form. So the easiest thing that we can do here is just replace row 2 and row 1 here. So we're just going to swap those out. So we're going to put row 2 on top. We're going to just switch it with row 1. All right. So if we do that, the new matrix, well, we'll just change places. So I want to have the first leading term of a 1 there. That's already done for us. Okay, so I'm just going to rewrite this here. Second row is perfect. We have a 0 there. 1, 1, -2, -3, and the other rows don't change. Didn't do anything to those just yet. Okay. So that's the first step that we're going to do here. And this is all like a algorithm to solve this. It's actually pretty interesting that we have these algorithms like this to solve these linear systems here. Okay. So the next thing we want to do here is we're going to do 2 times R1 and then add that to R3. Okay, so we're going to do 2 So negative 2 times R1 plus R3. And then what we're going to do is do negative R1 plus R4. Now, the reason why we're doing negative 2 times R1 plus R3, because my leading term on R3 is a 2, and I want to get rid of it. So if we do negative 2 times R1, everything in R1, remember, is multiplied by negative 2, and we add those results to R3, and that's going to cancel that leading term to a 0. Okay? Now we do the same thing for row 4. In row 4, the leading term is a 1. We want that to be a 0. So we multiply negative 1 times R1, and we can cancel that out. So the new matrix, once we do that, will be, so my row 1 stayed the same. I didn't do anything to it. Okay, R2 stayed the same, but R3 and R4, they changed with that operation that we just did. Okay, so that becomes 0, 0, 3, negative 3, negative 6, 0, negative 6, negative 6, negative 1, and negative 21 there. Okay. All right, so that was negative 1 and negative 21. Okay. All right, so at this point, and there's lots of different ways to get this matrix the way we want it, but we could swap R4 and R3 right now if we wanted to, but what I'm going to do is I'm just going to do this operation here. I'm going to do 6 times R2. Okay, 6 times R2. And I'm going to add that to row 4. Okay, the reason why I'm doing 6 times R2 is because my leading term on R2 is a 1, and I want to cancel that leading term of R4 and get that to a 0. Okay, then I'm just going to add that to R4. So the only thing that changes is R4. The new matrix becomes, once we do this rule, we'll have 1, 2, negative 1, 0. So these rows, again, do not change. Okay, so an R3 didn't change either. Okay, but R4 definitely changed because we wanted it to change. We wanted to get rid of that term there. Okay, so now I have negative 13 and negative 39. All right, so we're almost there. The only thing I see here on R3, I have a 3 there, and I want that to be a 1. And on R4, I have a negative 13, and I want that to be a positive 1. So what we need to do here is multiply R3 by 1/3. Okay, so I'm going to do 1/3 times R3. And then we just need to do negative 1 over 13 times R4. So negative 1 over 13 times R4, which will get rid of those leading terms there. And that matrix will look like this once we're all said and done. And this is actually a pretty cool puzzle to do here to get these matrices into row echelon form. And it's not too bad, just a little puzzle. All right, so here's the final matrix. Once we did all of our little operations, that's what we get. So we have our leading terms that we want. Okay, and notice this is not reduced row echelon form because above those ones they have to be zeros, and if you look at row 2, above that one, that leading one is a 2, so that wouldn't work there. All right, so let's write this back into the linear system. So I have x plus 2y minus z, and I'll leave a space there to show that there should be a place for that w there, equals 2. I'm going to have y plus z minus 2w equals negative 3. Then I have z minus w equals negative 2. Then I have w equals 3. So now all we have to do is do back substitution. So we know what our w is. Let me just do this real quick. So we know what w is. W equals 3, because on the last row, we have w equals 3. So we kind of work our way backwards. Now we do our back substitution. Back sub, okay? So to find z, we can just substitute in 3 for that w on that third row. And we'll get z equals 1. W, z equals 1. On the second row, remember it was y plus z, 2w equals negative 3. Okay, so we know what z is, we know what w is, so we can figure out what y is. Z was 1, we just found that out. W was 3. And we can simplify this up a little bit. 1 minus 6 will be minus 5. And equals 3. And when we, actually equals negative 3. Didn't see that negative. There's a negative right there. Yep, negative 3. All right, so this will be, when we get done with that, y will equal 2. Okay, so we're almost done. We got our w, we got our z, we got our y. The last thing we need to do is figure out what our x is. So remember our x, first row, looked like this. We know what y is. Y we found was 2. We know what our z was. In this case, z was 1. And there was no w on that first row. Okay, so plus 4 minus 1 equals 2. X plus 3 equals 2. X is going to be negative 1. So our final solution set, well, would be x equals negative 1, w equals 3, z equals 1, and y equals 2. So we just solved a problem with 4 variables.